This video is going to be all about water and why water is such a strange molecule. We interact with water so often on a day-to-day basis that I feel like no one really sees it as strange or out of the ordinary. However, water really is that strange. Compared to all compounds that are close to water in size or mass, only water is actually liquid and under normal Earth conditions. Everything else is in the gaseous state. So, if water behaved like most other molecules, it would be in a gaseous state right now. There wouldn't be liquid water at normal Earth conditions. And that would be really, really sucky for life in the fact that, it wouldn't exist because liquid water is where life originated. Um, Obviously, we deal with water every day, and the fact that our bodies are 60% water. The earth is, the majority of the earth is water. Um, the food that we eat, a lot of it is water. So, because water is liquid under normal earth conditions, that has allowed all life to be possible. And what makes water so strange is its extreme polarity. So not only is water polar and held together with polar covalent bonds, but those bonds are so much stronger than even normal polar covalent bonded molecules. And its polarity gives it partial charges, which allows it to form hydrogen bonds with itself, which we will see many water properties are due to the hydrogen bonding between water molecules. So before I get into the different water properties that are important for the AP exam, I do want to briefly review the types of bonds that are used to hold water together and the difference between the polar covalent aspect of water and the hydrogen bonding aspect of water. So let's review that a water molecule, the oxygen and the hydrogens, are held together by a polar covalent bond, which means that oxygen shares its electrons with hydrogen and vice versa. However, what makes polar covalent molecules unique is that they do not share their electrons equally. This causes partial charges to occur around the oxygen end and the hydrogen end of a water molecule. Because oxygen is more electronegative than hydrogen, the electrons spend more time revolving around the oxygen atom, which is going to give it a partial negative charge. Now, in chemistry, the partial negative charge is sometimes written with a lowercase delta, and all that means is partial. It's not like an anion where it has a full -1, -2 charge. It's just a partial charge, which means it's a little bit weaker. On the other side, we have the hydrogens, which are going to have a partial positive charge. And this is because the electrons are not spending as much time by the hydrogens. So those negative particles not spending as much time down here, so they're going to be positive. Spending more time up here with oxygen, which is going to cause that region of this water molecule to be negative. Why this is significant is now that this water molecule has these partial charges, it can actually create hydrogen bonds with other water molecules. And the reason why hydrogen bonds are formed is because the way forces works is opposites attract. So the negative end of the oxygen region of one water molecule may be attracted to the positive hydrogen region of another water molecule. When these water molecules approach each other, that is going to form a temporary hydrogen bond, which is sometimes written as multiple dots. And this bond is very weak, so it'll likely form and break, and then the water will, if it's liquid especially, will keep forming and breaking the same hydrogen bonds with different water molecules again and again as they all flow together in a liquid state. So the hydrogen bond is not what holds a water molecule together. It holds multiple water molecules together. And one water molecule can form about 4 hydrogen bonds with surrounding water molecules. So now that we've reviewed what holds water together, we can start getting into the various properties of water, starting with the first property is that water is a universal solvent, meaning that it can break down and dissolve many other different types of compounds, both ionic and covalent. So we'll go ahead and look at an ionic example in that table salt will dissolve in water. As you can see here, I've drawn a clump of sodium and chlorine ions that are salt molecule and then 4 water molecules. Obviously, if this was a real beaker in real life on a molecular level. You would have millions of each. However, that would take me super long to draw, so I've just drawn 4. So, noting that the oxygen region of every water molecule has a partial negative charge, and the hydrogen region of every water molecule has a partial positive charge, we can see that as water moves around in its a fluid solution, it is going to encounter these ions that hold together our salt. So when a negative region of one water molecule encounters the positive region or the sodium ion, what will actually happen is, using the sort of opposites attract concept, it will pull that sodium towards itself and bond with that sodium. This has obviously pulled apart a little piece of our salt molecule. So again, another water molecule is going to pull on these different parts. The positive regions are going to pull on the chlorine, and you can see now our salt molecule has been broken apart. So that in a nutshell is essentially how water's polarity allows it to be a universal solvent, because of its slightly positive and negative regions pulling on the slightly positive and negative regions of other molecules. The next property is going to be something called cohesion. So if you remember that the prefix co means together, that should help clue you in on what cohesion is. So cohesion is the concept that water molecules will stick together using their opposite charges because of their polarity. So cohesion is essentially what we call the hydrogen bonding between water molecules. And that just occurs because of the negative oxygen region and the positive hydrogen region. Again, hydrogen bonding is the reason why so many water properties are possible. That brings us to our next water property, which is adhesion. So when you hear the word adhesion, I want you to think more of adhesive, and think adhesives are things like tape. And tape is used to stick one substance to another, typically. So adhesion with water is not when water bonds to itself, which is obviously cohesion, but when water bonds to another hydrophilic substance. The biggest example of adhesion and actually cohesion working together is going to be a phenomenon called transpiration, which is when plants take up water from their roots and it travels up against gravity all the way through the plant and out of the shoots. So this could be a tiny household plant, or it could be a giant redwood tree where water is traveling literally stories high. And this has come up again and again on the AP exam. So just know that it is a combination of water binding to itself with cohesion, and adhesion, where water will stick to the sides of the plant cell walls, which are hydrophilic. This will allow water to travel up against gravity by pulling on each other, kind of like a chain. So as one water molecule evaporates out of the stomata, which is like little plant cell openings, it will pull on the water molecule beneath it, and so on and so forth in a chain-like motion. So as this one goes up, it's going to pull on all the others behind it. And the adhesion is going to help the water not slip back down to the roots, because it's kind of climbing its way up by sticking to the sides of the plant cell walls, which are hydrophilic. If the plant cell walls were hydrophobic, this water would just slip down and it would just stay and pool in the roots area, and it would never reach the shoots, and plants wouldn't exist. Humans wouldn't exist because they're the bottom of the food chain. So it's actually super important that transpiration occurs correctly, and it's all due to water properties. So that's going to bring us to our next water property, which is that ice actually floats. And that might seem like a no-duh type of moment, but it's really actually quite unusual that ice floats, because that means that water is actually less dense as a solid than it is a liquid, which is why jumping off the high dive and smacking into the water below hurts, because water is quite dense as a liquid. And ice floating is actually super important to ecosystems, because ice freezes at the top of, say, a lake. Aquatic organisms, if ice didn't float, if ice was more dense than liquid, the entire lake would freeze solid, and that would kill all of the aquatic life, and that would perpetuate throughout every aquatic ecosystem and cause things like the oceans to freeze when it got cold, especially in the past. way geological past with Earth. So it is extremely vital that ice floats because otherwise aquatic life would not exist. It would not be possible. So again, another great aspect of our planet is attributed to another water property. The next water property is high specific heat, which is the concept that water takes a lot of energy to heat up by 1 degrees Celsius. And this can be kind of annoying when you're trying to make your macaroni and cheese and it takes super long for the water to boil. And the reason why it takes so much energy to heat water up is because when you're heating water and you want it to evaporate, you have to use enough heat to break both the covalent bond between the oxygen hydrogens and the hydrogen bonds between the water itself. And that's why it takes so long. Your body temperature getting super hot in the summer because your blood is boiling, which would be terrifying and horrible. It also keeps coastal regions of countries, including the United States, super mild temperatured because the ocean is a huge body of water that absorbs a lot of heat and releases a lot of heat. So it keeps places warm in the wintertime and cool in the summertime, which is why Death Valley is 120 degrees and San Diego's sitting at a cool 72. This is also the reason why island countries like England maintain a decently warm temperature, even though they are about as north as Canada is. So it's really important when you have a coastal region that that ocean regulates temperature because it regulates the ecosystem biomes and it keeps a nice stable climate. It's also why those places are pretty desirable to live. The last water property is surface tension, which is the concept that water molecules at the surface of a body of water, so maybe the top of a lake or a top of a water glass, create stronger bonds with each other than water molecules that are at the middle or the bottom of a lake or a glass. And this is going to create a sort of film over the top of water that makes it strong, and you can actually set things on top of it sometimes, like a paperclip or this Jesus spider. And the reason this is possible is because your surface level water molecules are not being pulled by anything above them. So that means they can create stronger bonds with those water molecules next to them, and they're able to pack together a lot closer, which creates this sort of net-like illusion that water is sort of, you can almost imagine it's woven together at the surface, and that is just because it is not interacting with water molecules above it. So that, in a nutshell, is all of the properties of water and their importance and connections to why life on this planet is possible.